Please consider subscribing to our channels and consider switching on closed captioning for a better understanding of the vocabulary used in this video. High above us, invisible to the naked eye, powerful rivers of wind snake their way around the globe. These are the jet streams, constantly moving, shifting, and shaping the weather patterns we experience on Earth. They are a testament to the dynamic forces at play in our atmosphere, driven by solar energy and influenced by Earth's rotation. Understanding jet streams is key to unraveling the complexities of our planet's climate system. The jet streams form at the boundaries of contrasting air masses, where warm air from the tropics meets colder air from the poles. This temperature difference creates a pressure gradient with air flowing from high pressure to low pressure. This flow, however, is not a straight line. Instead, it curves, influenced by the spinning of our planet. The jet streams are most pronounced at altitudes where commercial airplanes fly, typically between 30,000 and 40,000 feet. Here, the air is thinner, allowing these wind currents to reach incredible speeds, sometimes exceeding 200 miles per hour. These high-speed winds have a profound impact on weather systems, steering storms, and influencing temperature patterns across the globe.
On the polar side, or in other words, the northern side in the northern hemisphere of the jet streams, clear air turbulence is often encountered. This type of turbulence is particularly dangerous because it occurs without any visual warning. Clear air turbulence is caused by the interaction of different air masses and the wind shear within the jet stream. Pilots must be vigilant and rely on pilot reports and aviation graphic forecasts to navigate these turbulent zones. Specifically during the pre-flight procedures, observing SIGMETs and the constant pressure charts such as the 500 millibar chart, and while in flight, air traffic control communications to the flight crew of pilot reports of turbulence ahead of them. Examples of clear air turbulence include sudden jolts and drops in altitude, which can be unsettling for passengers and challenging for pilots. Understanding and predicting these turbulent areas is crucial for aviation safety. To determine where clear air turbulence will be found using a constant pressure chart such as the 500 millibar chart, look for the following indicators. 1. Height contours. When the contours are closely spaced, it indicates strong winds and potential turbulence. 2. Wind shear. Look for significant changes in wind speed or direction over a short distance. This can be a strong indicator of turbulence. 3. Vorticity. High vorticity values, shown by small, tight loops in the height contours, can signal turbulence. Vorticity is a measure of the rotation of a fluid, or the twisting motion in the troposphere. 4. Jet streams. The core of a jet stream often has strong wind shear and is a common source of clear air turbulence. Notably, the polar side of the jet stream tends to have more intense turbulence due to greater temperature gradients.
By analyzing these factors on the 500 millibar chart, which represents approximately flight level 180 or 18,000 feet, pilots can identify regions where clear air turbulence is likely and plan their routes to avoid it. 2 significant incidents involving clear air turbulence have occurred recently, highlighting the dangers faced by air travelers. On May 20th, 2024, a Singapore Airlines flight SQ321, a Boeing 777, encountered severe turbulence over the Irrawaddy Basin in Myanmar. The turbulence caused the aircraft to suddenly drop in altitude, resulting in the tragic death of a 73-year-old British man and injuries to at least 30 other passengers. The flight, which was en route from London to Singapore, had to be diverted to Bangkok, Thailand, for an emergency landing. Another notable incident occurred on August 29, 2023, involving Delta Airlines flight DL-175 and Airbus A350. The flight, traveling from Milan, Italy, to Atlanta, Georgia, experienced severe turbulence as it approached Atlanta's Hartsfield-Jackson International Airport. Although there were no fatalities, the turbulence resulted in injuries to 11 passengers and crew members, who were subsequently taken to the hospital. The aircraft landed safely in Atlanta, but the incident underscored the importance of wearing seatbelts and being vigilant about turbulence risks. These events highlight the unpredictable nature of clear air turbulence and the critical need for precautions in aviation.
The Coriolis effect, named after French scientist Gaspard Gustave Coriolis. Jet streams are influenced by the Coriolis effect. The Coriolis effect caused by the Earth's rotation, deflects wind patterns to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection helps to establish the west to east flow of the jet streams in both hemispheres. Imagine throwing a ball straight north from the equator. While the ball travels in a straight line, the Earth rotates underneath it. To an observer on the ground, the ball appears to curve to the right, as if acted upon by an unseen force. This apparent force, the Coriolis effect, is not a true force, but rather an illusion caused by our frame of reference on a rotating planet. It impacts anything moving freely across large distances, including air masses and ocean currents. The Coriolis effect plays a crucial role in the formation of jet streams. As air flows from high pressure to low pressure, attempting to move in a straight line, the Coriolis effect deflects its path. This deflection is to the right in the northern hemisphere and to the left in the southern hemisphere. The result is a curved flow of air, forming the jet stream patterns we observe.
The jet streams are not static entities, but rather dynamic and constantly shifting ribbons of wind. The boundary between the jet stream and the surrounding air masses is particularly turbulent. This turbulence is most pronounced on the polar side of the jet stream, where the contrast between cold, dense polar air and warmer air within the jet stream is greatest. Imagine two bodies of water moving at different speeds colliding. The interface between them would be chaotic, with waves and eddies forming. A similar phenomenon occurs at the edge of the jet stream. The sharp difference in wind speeds and temperatures creates a zone of instability, leading to the formation of waves and eddies in the atmosphere. These atmospheric waves and eddies manifest as turbulence, a significant concern for aviation. Pilots carefully monitor jet stream locations and turbulence forecasts to ensure smooth flights. This turbulence, however, serves an important purpose. It acts as a mixing zone, transferring heat and momentum between the jet stream and the surrounding atmosphere, contributing to the overall balance of Earth's climate system.
Section 4. Jet streams as weather architects. Jet streams play a crucial role in shaping weather patterns across the globe. They act like giant conveyor belts, transporting warm, moist air from the tropics towards the poles and cold, dry air from the poles towards the equator. This constant movement of air masses influences temperature, precipitation, and storm development. The position and strength of the jet stream can significantly impact regional weather. A strong jet stream can bring warm air northward, leading to unseasonably warm temperatures. Conversely, a weak or southward dipping jet stream can allow cold Arctic air to plunge southward, bringing frigid temperatures and winter storms. The jet stream's influence on storm development is particularly significant. Storms often form along the jet stream, where the contrast in air masses provides the necessary ingredients for their development. The jet stream can then steer these storms, guiding their path and influencing their intensity. Understanding the jet stream is therefore crucial for accurate weather forecasting.
Section 5. Conclusion. The jet stream's global influence. The jet streams, high above our heads, are a testament to the intricate workings of our planet's atmosphere. Driven by solar energy and shaped by the Coriolis effect, these powerful rivers of wind play a critical role in regulating Earth's climate. They constantly redistribute heat and moisture, influencing temperature patterns, precipitation, and storm development. Understanding the jet streams is essential for comprehending the complexities of our planet's weather and climate. By studying these high-altitude wind currents, scientists can gain insights into the forces that shape our planet's environment and improve our ability to predict and prepare for future weather events. The jet streams serve as a reminder that Earth's systems are interconnected, with seemingly distant phenomena having a profound impact on our daily lives. If you enjoyed this video, don't forget to subscribe to American Northwest Magazine and the American Northwest Aviation YouTube channels. Like, share, comment, and click the notification bell to stay updated with our latest content.